Lesson 10.3 is we're gonna look at parallelograms and trapezoids. So first thing is we want to understand what a parallelogram is. We have a sketch here. Pretty much a parallelogram is like a rectangle as if someone were to push it. Like they came over here and they pushed it, so it's slanted a little bit. And what it technically means is that you have two sides, opposite sides are parallel. So this side and this side are parallel. We're going to mark that with an arrow. That's what the arrow means. And this side are parallel, so we're going to mark it with two arrows to show that that's different than the one arrow. So these sides are the parallel sides. That's what a parallelogram is. It has two sets of parallel sides. Okay, now in a parallelogram we want to identify a few different parts of it. This bottom part is going to be known as the base, and then when we go ahead to label the height, they're going to give you a line coming straight up and down and mark it with a right angle. And as we saw before with the triangle, when they do that, it almost looks like an H, helping us to remember that that's our height. We don't want to take this slanted side as the height because, as if you were at the doctor, when you go to get measured for your height, you don't slouch or slant, you have to stand straight up. So straight up and down is our height, across the bottom is our base. Perimeter, we're going to add up all the sides. And then to find the area is actually just going to be base times height, same as it is for the formula for a rectangle, length times width or base times height. And the reason is, see if you can follow this. If this is our parallelogram, okay, now if I take this piece out here and I kind of slide it over, and again, we'll look at this in class, it'll be easier. If I slide it over, that's going to fill in this portion. And notice what I'm left with is a rectangle. And that's why the formula for area of a rectangle is the same as the formula for area of a parallelogram, because essentially it's the same figure. You're covering the same space, it's just arranged differently. So base times height, bottom times whatever the height is that they represent with a right angle. Special features, 360 degrees, and as we saw before, two sets of parallel sides. Alright, so we are allowed to use calculators in this. They want us to find the area of the parallelograms listed below here. So formula is area equals base times height. My base in this case is 14. My height, I look to see where the straight up and down with the right angle is. It's 10. So 14 inches times 10 inches, 140 inches, and because it's area, you have to label it squared, which is part of the notation, 140 inches squared. Letter B, we want to find area again, so it's base times height. Now this one's oriented a little bit differently, but again, if we look for that right angle, it's going to help us find the height. Because all we're doing is multiplying, it doesn't really matter the order, but it's good to recognize the parts for what they are. So that means that my base is going to be 5 feet, even though it's not flat. Again, we look for where the height is, and that tells us that our height is 3.5. And because the only other thing left was 5, that must be our base. So 3.5 times 5, our area is 17.5 feet squared. Letter C, area equals base times height. My base here is going to be this 5, and my height with the right angle is 2. So I find out that my area is 10 meters squared. Let's take a look at example 2. The base of the parallelogram is 5 inches. The height is twice the base. Find the area. Alright, so here we have to draw it out. The base of our parallelogram is 5 inches. The height of this parallelogram is twice the base. Well, since the base is 5, the height must be twice that, or 10. Find the area. So it's going to be 5 times 10, or 50 inches squared. Not too bad. Example 2, you try. The base of a parallelogram is 10 meters. The height is 1/4 of the base. Find the area of the parallelogram. So I'm going to sketch out a parallelogram just so I can see it. It's always good to see what you're doing. The base is 10 meters. Now it goes ahead and tells us that the height is 1/4 of the base. So it's 1/4 of 10. Now if you aren't sure what that is, you can't think of it. It's 1/4 of 10 because it says 1/4 of the base and the base is 10. You can do 1/4. We know that of means to multiply times 10. Or you could make a proportion. You could do 1/4 is equal to x over 10. No matter what you do, you're going to end up getting 2.5, because you would do 0.25 is 1/4 times 10, and you're going to get 2.5. So this distance here is 2.5 meters. When I go to find my area, base times height, it's going to be base is 10, my height is 2.5, so 25 meters squared. Okay, all right, let's take a look at, now we're going to turn the page and try some work with trapezoids. And trapezoids are very closely related to parallelograms. A trapezoid starts out kind of like what a rectangle looks like, but now we have two slanted sides and they're going in opposite directions. So the criteria for a trapezoid is you have one set of parallel sides, these here, and that's it. That's the only thing. You have one set of parallel sides. Parallelogram had two because it had this parallel and this parallel. Here, these two sides are the same, so we only have one set of parallel sides. And just like before, we have some labeling to do. This is going to be our height. It makes the right angle. Now, because we have two different sides here, we're going to call them in their different lengths. This is obviously shorter than this one. We're going to call this base 1, and we're going to call this base 2. You could invert them. You could make this base 1 and this base 2. That's not really all that crucial, but you need to know that they're both different because they're going to be different lengths. So we want to make sure we take note of that. The book does an excellent job. There's an explanation of how the formula comes about for area, which we're going to look at here. And so I would recommend that you look that over if you missed class. We'll talk about it in class where it comes from. It's kind of neat just to know the background on the formulas. But all right, so let's get into the formulas. Perimeter, you're just going to add up all the sides just like before, as we always do. And that keeps it nice and simple. Now for the area of a trapezoid, it's going to be 1/2 times base 1 plus base 2, close parentheses, times the height. Now there's a lot there, but I want to focus on a few things. We put these little marks down here, 1 and 2. I didn't put them up above because it'd look like exponents. We don't want to put them in the front because it'd look like coefficients. So here, this is just notation saying this is base 1, the bottom, and this is base 2, the top. So base 1 is down here, base 2 is up here. This is my height. And the only other thing is 1/2 in front. So we're going to multiply all of these, obviously following order of operations. Okay, and then our special features, 360 degrees to our triangle, or I'm sorry, a trapezoid, and we're on our way. Let's try a couple problems. First one, find the area of the trapezoids below. Okay, so we have these two different bases, so we're going to pull on our formula, 1/2 base 1 plus base 2 times height. And then we go ahead and fill in all the pieces that we need. Base 1, I said, was, in our examples, we labeled at the bottom. So base 1 is 9, so I'm going to have 1/2 times 9 plus base 2 is 3. And my height is 8.5. It goes with that right angle. So 8.5. Now I could put this straight in my calculator, right across, putting all the parentheses in. I can follow order of operations, which means I would simplify that first. And then from here I can do multiplying everything together to find out that we get 51. So 51 meters squared is our area. Okay, let's try letter B. Area equals 1/2 base 1, parentheses, plus base 2 times the height. Base 1 is 22, base 2 is 15, and the height is 11. So I'm going to go ahead, add what's in parentheses to save myself a little bit of work. I get 37. And now I can multiply everything times itself. Again, you can do that all in one step, that's fine, but I do need to see the values substituted into the formula to know that you're understanding where to get the information from. 203.5 inches squared.